Hi everyone. I'm Gil and welcome everyone who came for this today's webinar, which is going to be about unit testing for grown-ups. The topic of this thing is mostly about the mindset of unit testing, but because in the last few weeks I managed to give a sort of presentation like that a couple of times, mostly for managers and team leaders. And it's not about the tools, because tools, it's very easy to read about them in the internet and get the feeling. But when you're talking about managers and team leaders, um, they need to understand first what's the impact, and it's going to be real impact there. And I'm going to talk about that. And there are fears, there are objections, especially when they're trying to implement that at with their own teams. So I wanted to talk about that, and this is what this session, how it came to be, and I hope you will enjoy it. If you have questions, there's a Q&A panel you can use. And there's also the chat window, but I will mostly answer from the Q&A panel because it will be easy for me. For the people who don't know me, my name is Gil, Testing Gil. I'm a consultant. I work with teams on implementing all kinds of practices for developers and testers and agile people, whatever. I help everyone who work on software, and sometimes not even software, on producing products. I have a couple of books. One of them is called Everyday Unit Testing, and the other is called Everyday Spring Testing, which is in the process of writing. And by the end of this session, I'm going to make a sweepstake, and one of you, or maybe two, will get this book for free, Everyday Unit Testing. So when I start talking about unit testing, basically I say, wait a minute, let's not talk about unit testing. Unit testing is a method. It's a method to get to somewhere. What do we want? And for developers, when I ask them, what is your job? And they say, well, we build software. And I ask, really? Why? And there's a reason. They have to think about it, why they're building software. After all, I'm a developer. I started developing software, I think, when I was 10. Building software is like something of its own, but I want to dig deeper, and we're building software not sometimes for fun, but when we don't do that for fun, we still do it not just for the sheer fun, but we're kind of solving problems. We're solving problems for people in the organization. We're solving problems for our customers, and we're building all kinds of tools and processes and all kinds of software to solve things. They want things done. What do they want? From business processes to gaming, it doesn't matter, but we kind of enable them to do that. And there's one more thing that we forget to mention, but it's kind of in the back of our heads, is that we're not doing it once. We're doing that over and over again. Building software is an iterative process. So what they want, our customers, regardless of who they are, whether outside or inside the organization, they want their problems solved, and they want them solved fast. And remember, they want them solved fast every time. So basically, if you take it down to the level of the developer's job is to create code that works, and it's easy to maintain. Code that works means it solves the business problem that we want. But more than that, if it's easier to maintain, we'll be able to produce this code that works iteratively. We're going to add new features. We're going to modify things. And these things also need to be fast. So whenever I show this to developers, they kind of think about the top part, but It kind of has to sink in about the bottom part as well. Now, we as developers, if you think about it, there's two parts of our job. One is a lot bigger than the other, which is we change code a lot. Everyone who's been part of writing something from scratch knows how he felt about the freedom of writing everything he wanted ever. I remember doing this a couple of times, and it was fun for the first 3 hours, because after that I had to start changing the code. Most of our life is changing code. And we need to remember that, because the other part of the developer's job, remember, we have to keep it maintainable so we can produce things in the same consistent, fast way. We're going to change code. So we need to do that without breaking stuff. The more code we have, the more we move forward in the timeline and we add stuff, the risk of breaking gets bigger, because most of the time we're changing code. Changing code means that something worked before. If we're changing that, there's a risk of breaking that. And the more code we have, there's a risk of breaking more stuff. And we don't want that. So, sorry, Hulk, yeah. We need to remember that, because that's the most motivation that we have. And when we tell developers, yes, we're going to introduce a new process, and basically we don't want you to break stuff. But we're going to dig a little deeper than that, because we want to talk about economics, and not just the money, because that's really the thing. I'm going to talk about the economics of time, because we don't think about that a lot. And I'm going to start with the bugs, because as developers, I know I've been there, I'm still doing that, but especially for people who haven't incorporated too many new practices, and unit testing is not new, obviously, but one of them, it's about part of the developer's life is bugs. And I talked about changing code, so obviously we have the danger of introducing bugs. I want to talk about the impact of bugs, though, like the big one there. So there's when you think about bugs, we think about two of them, two types of bugs. First one is the big ones, where we need to stop everything, and everybody stop what they're doing, just go fix the bug. There's something in production that we can't solve. We need this to be solved now. And when we're doing that, everybody accepts that, yeah, obviously this is very important. Everybody stops what they're doing, and that means we, the organization, we accept the cost, because obviously this is something that needs to be fixed. But most bugs are not like that. Most of the bugs, we just seem to work through them because we decided that they are important to fix. But if you're looking at it from the developer's eyes, it's part of their job and therefore part of its time. However, we need to look how real time, because we conceive it like this. We conceive it that basically the development time means the development, and then there's testing. But everybody knows there's going to be bugs, right? So the real development time is going to be like 2 cycles. There's going to be a development time, and then there's going to be some testing, and there's going to be bugs. So we're going to turn back to the developers, and it's going to do his job and do testing again, and then this thing happens. But that's not really the real thing, right? Because the real thing is we're building stuff in teams. And that means it's not a single developer's view of their time, that they're kind of spending more times on the bugs. No, we're kind of introducing delays into the system. So if you look at the right column, what happens there is that there are two developers working. They're integrating their work, and they go into the testing part, and then we find bugs. Some of them belong to developer number 2, but there are a few of them. But developer 1 got the major bugs, and he has to work a bit more. So developer 2 waits for him. He may be doing some stuff, but he's probably doing it very slowly because he's waiting for the call that from developer 1 saying, yeah, I'm finished, let's do integration again. And they do integration again, and they do testing again, and there are bugs, and it goes on and goes on like this until we actually finish. So when we're estimating the stuff, we ask the developer how long will it take, we're kind of looking at the left part of the screen. But if we're actually looking at the actual development time, when we actually put something at the ends of our customer, when we solve their problems, this point gets away from the beginning. The complex the code, more people are working on it, and the more bugs there. And obviously, we'd like to squash this thing down. If you think about it, it's not just for two people. It's like a ripple effect, because when the developers get delays into their work, which means bugs, they cause other developers to wait for them. And those other developers wait for them with the integration, and therefore the integration delays the testing. And testing, kind of our gateway to our, yes, it's live, doesn't go live completely. Maybe it does, but it has to go through maybe marketing and salespeople who need to train on the new features that we're producing, and they need to train the support team maybe. And then if we go to the other side or the customer side, they're waiting. So if we're kind of waiting and waiting and waiting and waiting, this grows exponentially. And when we're thinking about we're working in the organization for money, basically, remember economics, the ripple effects gets longer and longer, and the impact gets bigger, and the time between the problem, or we're even starting to work on the problem, not the bug, starting on the work, what we're trying to solve, and the end where it's in the customer's hands working, this gets longer and longer. And the longer it takes, money doesn't get in. And it's not like we're doing this for the money. We're doing this for solving problems. So the customers don't get their problems solved soon enough. And that's the cost of bugs. The real regular bugs, not the production ones, the production or holding ones. Everything that we do, that we enter as bugs in the system, has a cost. And because of that, we'd like to minimize this number. So maybe you know about shift left, means we're going to test as early as possible. And unit testing is obviously a part of that. Now we need to remember that all thing, again, is not a one-shot. Development is iterative. It doesn't matter if you work in an agile manner or not, you produce stuff iteratively. So if you write unit tests or any automated tests beforehand, the earlier we put them in, they will give us a value because they find stuff that we break because we're going to break stuff. Okay, that's not going to disappear, but we'll know about them earlier and we can reduce this timeline. And we can produce code that works now. With our tests, we can prove that. And it will work later because our tests will tell us it is still working and you haven't broken anything, or it's broken. Go fix it before the customer gets it and before we create more ripple effects. One more thing that we forget to talk about, but we need to remember that tests are like documentation. So if you think about solving the problem for the customer, which means writing the software for that, that means that if a new developer goes in, he needs to learn where to change the code, how the code works, where not to touch because it's going to break. So with tests as documentation, as a feedback mechanism, they can change stuff earlier and without that risk of breaking anything in production. Again, squeezing the timeline to get things earlier into production. So time to market, whatever our market is, whether it's internal customers or external customers, decreases. Now, automated tests is, from my experience in the last more than almost 30 years now, is the best way to squeeze this thing. The only things that comes close, which is not automated, is code review, putting more eyes on the code. But effectively, they work together even better. So automated tests and unit tests are the way. Now, I'm going to show you something that you've probably seen before. What kind of tests, if automated tests are indeed the way, what do we need to write? And you've probably seen the pyramid one or twice or 30 times in your life. The roots of this, by the way, is called the automated testing pyramid. Today, you'll see things like manual testing at the top. And the model speaks about what it tries to tell you what kinds of tests you need. And the pyramid tells you that you need more things from the bottom than from the top. Why? Well, if you think about it, this is a model of cost. Unit tests are easier to build, easier to run, easier to set up, and basically they're a lot easier than the things at the top. The more, the longer the code path that we want to cover, it's going to take more effort. But let's think about it mathematically first before we jump into reality. Here's an example. You have two components. Each has three methods, A, B, and C, and X, Y, Z. A calls X, Y, Z, B calls X, Y, Z, and C calls X, Y, Z. So if we want to cover everything, we need in an integration test to cover a X, a Y, a calling Z, all this, including if you sum it all up, it gets to 9 tests. If you do just the unit test, which means you test A, B, C, X, Y, Z in isolation, you get to 6. That's pure mathematics. And if you think about it, if you take these numbers and think about all the types of combinations that you're going to have, the unit tests are going to the number is going to be go up linearly with the length of the code, and the number of combinations is going to be exponentially. We all know that. But we seem to forget something, because the numbers, yes, I'm not saying they're lying, but in real life, what will happen is that I'm going to tell you that it's going to take 9 integration tests to cover everything. In real life, it's going to be like 40, but it doesn't matter right now. Let's stick with the 9. These 9 are basically harder to write than the 6. The larger the number of integration tests, basically that's it. The more we integration tests pass that we want to test, the more the chance that the developer will say, I'm not doing that. That takes up too much of my time. It breaks all the time. These things are fragile. I'm spending too much in the test. And the dream of full coverage, we never get there. Okay, so we need to remember that mathematically, yes, unit tests cover more with less tests. But more than that, we're not going to achieve actual full coverage, because basically the human beings who are going to write them are going to say, no, we're not going to do that. So if we want to introduce the thing, the new practice of automated tests, and we want to instill it, our chances are bigger going with the right one, with the unit test, because they are easier. we need to think about it this way. Um, if you compare longer paths and shorter paths, first of all, there's the confidence level. I told you the pyramid is a model of cost, which is the bottom part. I'll talk about it in a minute. But if we're talking about confidence, it's not the same way. I can have 1,000,000 unit tests. And if that's the only thing I have, I still don't have the confidence that my application works correctly. That's why we have a pyramid. We need a few longer paths automation. But if we just wrote all of them, then we come to the cost. It costs too much. Longer paths to cover, they have bigger setup, they're harder to debug, they break on stuff other than our code. Well, unit tests are the opposite. They need, because they test a bit less of the code, they require the setup just for that code. They're easier to debug because it's just that code. And they pinpoint the problem because you're testing this kind of thing, and if this falls, it's probably in there. So that's where the model of the pyramid stands on. It doesn't do away with confidence because it doesn't deal with that. We still need more ways to make sure that our code works. But in terms of implementing a new process, we need to think about the cost and the objections, and the thing that if we're going to start with longer paths, people are going to break. And I'm not saying this because I know people. So we need to think about the mindset. And some of them is trying to think differently. I'm saying this as a developer. When I went into test automation and unit testing years ago, I started thinking differently. Testers are better at this than developers because developers are generally built up to build something. And when you tell developers, you go build that thing, they will build that thing for you. They will not ask how does this work, because first of all, obviously it will work. I'm building it. But other than that, yeah, there are going to be bugs, yeah, but that's somebody else's problem. And that problem about thinking about how we're going to test is something that needs to be taught. So I'm going to talk about the what ifs, the testing mindset soon. I'm going to start though with one of the things that we need to understand, which is kind of, I led to from the last part. We probably won't cover everything, but we don't need to cover everything. There are ways to measure coverage. I'm not talking about even coverage tools, talking about scenarios and stuff like that, things that actually mean something. But the mindset should be, we're not going to test, or we're not going to need to test everything. But we need to start thinking about things that might go wrong. Here you see a mind map of something that I give, part of my training is there. It's about cheese. But people who've done test planning know how to do this. And this is a skill, maybe even more than that, it's a set of skills of how to develop that. And there are techniques to teach that. Most developers who are leaving university or any school, they are not taught to do that. How to split things into cases and how to think about it. If you think about it, not from the tester's point of view, but from the developer's point of view, if you would think about these cases, and assuming that these cases need to be covered, there's going to be code for them. A lot of the bugs that we have are basically things that we didn't think about. So thinking like a tester and taking this down into the test level requires me as a developer to think, well, how am I handling that? And is the code handling that at all? So as a developer, I need the skill set, and as team leaders and software managers, we need to understand that this kind of thing of how to break down user scenarios to these are the pieces of the code, and therefore I need to unit test these scenarios as a unit. And what do I mock and why do I mock that? We need to teach the developers to do that as well. Again, these are skills. They are teachable. Some of them easy. Some people will get them more easily. Some other will not. But it is something that we need our developers to accept, that this is a way. This is not. They're not just going to use JUnit, and that means you're doing unit test. There's a lot more than that, because the practice requires a lot more than that. Now let's talk about objections. I hear that all the time. It's going to take twice the time that I'm going to write tests. Again, this is speaking about the mindset, not the actual discussions, although I think I'm having this kind of a discussion like once a week. So people are reluctant to do that. And some of them are developers, some of them are team leads and managers who are required or are used to pushing code into whatever, Bitbucket or GitHub or whatever they're doing, and say, this is where my job stops. But as we talked about, unless it's coming to the end, to the hands of the customers, job is not done. So let's talk about twice the time. Most of the time of developers is not typing code. Okay, so you can actually measure that. Most of the time, the developers develop is reading code, is understanding it, is reading documentation, is designing. A lot less of the time is actually spent typing. And we kind of mismatch these things. We think that we actually are writing code and we're going to write multiple tests for it. We're going to triple or quadruple the time we're going to do that. But that's not true, because typing time is very, very cheap. The mind time is a lot more important. And we need to remember that. We need to teach that to developers. So the code it may be doubled, it may be tripled, but that's not going to be the main thing. Because the main thing is that I want this code to be working at the hands of the customer. And that's only going to be at the end of all these cycles. And these cycles are going to be a lot shorter if we actually write tests. And that's what's important. In organizations that are not agile, developers are not working in a team with testers, are not working hand to hand with testers, regardless of how they're built. It's a new concept for them, because they are being measured by pushing code. So this is something that managers need to learn, and they need to educate the developers as well. I'm going to answer the questions at the end, so I'm going to continue. In a few minutes, I'm going to get there. So if you have any questions, put them in the Q&A thing, and I will get back to you. I promise. So you have to remember that typing is not the bottleneck. I'm joining this guy with my cup. And developers will, I know I was there. I was thinking in terms of me on the keyboard, but most of my work was not doing click. So we need to remember that. The second thing you'll hear, and this time it's completely true, is that the code is hard to test. And the reason it's hard to test is because we didn't test it until now. So all the skills and practices, clean code, testability, patterns that help us test more easily, like dependency injection and stuff, are not there. So when you're trying to test code that wasn't written to be tested, it's going to be hard. And remember, the developers, they're not evil. Those that actually want to do that will say, well, if this takes so much time, how is it going to be effective for me in the future? Because it's going to be the same time. So we need to teach developers, and we need to instill that they need to learn how to write code that makes this job easier, how to write testable code, clean code, use patterns like dependency injection, so we can create and mock stuff more easily. Think about singletons and global data or static data, things that are can be changed by multiple entries and create side effects, because the code was not written like, yeah, we need to make sure that this is not approached in different scenarios, because we didn't think about that. Exposing parameters through configuration versus hard-coded stuff. Again, we didn't think about writing it this way because we didn't think somebody's going to use it that way. And if we're doing testing and if writing tests, we are the ones who are actually thinking about these scenarios. So by doing the test, we're actually going to create testable code, but we need to learn this stuff. So some of them are kind of sometimes they're ingrained in the tools that we use. I'm using just from today in Angular, we're using dependency injection out of the box, so it's easier to inject stuff. But if you're doing something in a constructor with dependencies that requires other dependencies, it can be easier to write it, easier to test if you write it differently. So we need to learn, we need to teach these things, along with abstraction, encapsulation, modularity, all kinds of things that are part of what we call better design, better code, clean code, better architecture. It doesn't matter, these things go hand in hand with the stability. But these are skills that we need to teach and make sure our teams know about this, and assure them that when they do that, testing will become easier, their lives will become easier, and they will still reach that goal that we want to get there. I'm saying a few weeks ago, you have the date at the bottom. There's a guy called Mike Hill. I hope some of you follow him. Actually, he talks about Agile and TDD and stuff. He put out a lot of videos which are nice about TDD. And he wrote that in a blog post. He said, if you brought us a functionally correct design that required our app to run a million AWS instances, we'd casually say, no, that's not valid. So as developers, we kind of have the experience, the skills to say what a functionally working design, but something that's going to cost us a lot. For in this example, it's going to be like million virtual machines. We know that's not a valid design. And we need to start thinking like that and talking about like that as the same thing as with testability. So if something is not testable, if we haven't thought about how to test that, if it's hard to test, I'm not saying not testable, everything is testable. The difference is how costly it is to test it. So if it's not highly testable, we should discard it and look for another design. And as team leads, as senior leads or senior developers, we need to do that. We need to provide designs and say, well, this is how we're going to test it. This is the scenarios I was thinking about. Maybe somebody else was thinking about something else, but I'm providing enough access points, debugging information, and tests to say, oh, this is how I'm going to build it, this is how I'm going to say it's working, and at the end provide this thing with the tests. Process needs to change to support that. Now, I'm doing that whenever I can. It's not easy to do that, but there is one way to do that, and it's called TDD. Test-driven development, red-green refactor. For the people who know it, it's it really does look like this. From the many teams that I've taught to do that, not a lot of them stick to that. It's hard. It requires a lot of discipline. It requires writing code in a different way than our tools ask us to. We use a lot of frameworks like Spring in Java or in Angular, the code that I write. It doesn't lead you in a testable way. And it kind of breaks down when you say we're going to do to write this code in testable manner, because it kind of meshes up with the code, with the infrastructure code. So people know this is good for them, but TDD is not just writing about the tests. It's how about write the code, how to separate it from infrastructure code. TDD basically is a lot of skills. It is possible to do that. I worked with TDD as a TDDer for a couple of years, day in, day out. So it actually is possible. But my experience tells me, if you try to tell people, you start writing tests first and everything will be okay, no, that will not work. It starts with the mindset. It starts with why we're doing that. It's what we're trying to achieve. And it goes with the practices of actually writing tests, making the code testable, understanding there's a learning curve at the beginning, because there is going to be a learning curve. And as with any practice, instill it. Most of the people I work with and I've seen working, they continue to write test after rather than test first. Those that are managed to do that, at least in part of the job, are pretty happy, because this is like the accelerator of writing code. So okay, we kind of before the finish line here, I want to summarize what we did. We want to get here. We want to have the ability to write code that works all the time. Meaning we're going to be living in that code. We're going to change it. We don't want to break it. We need to understand that most developers have not been brought up to think like that. And therefore, there are a lot of skills, a lot of practices that we need to take to change the mindset, to instill that, to continue pushing that this is what we want to get to. And there are tools to do that. Unit testing, code reviews, automated tests, there are tools to get to working code that works right now, that will work later. We need to remember that these are new practices and these are not just new tools to learn. So we need to understand and teach and give it time to practice on how to design the code properly, how to write the tests properly, how to make sure that it is maintainable, to learn from experience when we're changing code. Most of the developers who learn that automated tests are good for them is when a test breaks for the first time. That was my experience as well. So this was my whole work until now. I just typed code which didn't do anything, but the first test fails. Now I understand. So we need to do that. And as managers, as grown-ups, as I've said in the beginning, this is what we need to teach. This is how we need to talk about unit testing and automated testing. These are things that basically bring us to this goal. And that's my story for you today. So if you have questions, put them in the Q&A box. I saw someone put the last thing in the chat, that singleton is considered an anti-pattern. That's not true. It's considered a pattern. It's in the design pattern book of the Gang of Four. Singleton is a good thing to have for the proper use. Imagine you're connecting to a database, so you don't want to manage multiple connections. So there's a good practice for that if you're using it correctly. It has other uses that singleton as a pattern is being misused in different scenarios that A, make it hard to test, and B, it's like, since it's a singleton, I give you an example. One of the last projects I worked on, for some strange reason, I can't really tell, but I've seen it somewhere, at least in this project, it was a Java Spring application, and the team decided to wrap the Spring application context in a singleton, which it already is, but in a wrapper of their own. And this required me to jump through hoops because they didn't give it a setter. So when I did some testing and I wanted to install my own application context, I couldn't. So this was not about doing about going through the singleton pattern, but controlling the accessibility of it. And again, this, if people knew about the stability, they would think about doing that. Okay, so I'm going to start going through the questions at the Q&A box. Please write, if you have questions or comments, put it there instead of the chat, because chat's getting too big for me to find stuff. Okay, so first question, if you have several thousands of unit tests, what is the easiest way to make any sense how much code they cover? Yeah, the answer for that is that really the question you're trying to answer? Yes, there are tools to make sure to count lines of code, but lines of code are not created equally. And I'm not talking about counting braces or not. Imagine if of code you have two functions, even if one single function, that you have an if and an else. Okay, the if part is run 1,000 times a day. The else part is once a year. If you think about this way, the if part needs to be covered. So even if they have the same line of number of lines of code, they are not equal. So how much of the code they cover is not really what you actually what you're actually after. What you're actually after is more in the context of scenarios. And that's the tough job, because if mapping back unit tests to scenarios, it's very hard. And it's kind of work. If you don't know if you're covering the right stuff, I'd suggest like stopping for a minute and thinking about what kind of things that we have. What are we testing automatically in terms of unit, in terms of integration or end-to-end? What are we doing manually? What's been working for a while, for 5 years now, and we haven't touched it? What's changing all the time, or where the bugs come from? So it really doesn't, it's not the right question you want to answer, and obviously this is not the question you asked, but it's a lot deeper of doing the analysis for what is actually covered, and does it make sense to you, and does it make sense to us at this point in time? Because if I do this analysis today and I do it in a year from now, the context will change dramatically. So it's work that needs to be done. It's usually work that's best done by a team with the testers, with the developers, and sometimes maybe even the product. What about unit test quality, wrong or missing assertions? Yeah, so at the beginning, testers will write ugly, bad tests. After that, they will copy those tests to other tests. So what you get is like the person says, As a result of this, you get unit test coverage that can be high, like 80%, but the quality, if the tests, they're not good as documentation. When one of them fails, you don't understand how it connects to another, and why this one failed and not the others, and what's the impact of that. And that's true. Again, as team leads, people who are instilling this process, it's our job to teach the developers how to write better tests. And again, this is not something that we've been born with. It's something that we need to review. It's going to be part of the test review and the code review. And we need to do that. It won't happen on its own, especially because at the beginning, the developers will not understand the impact of having a readable test. And that's why, and when they copy it, like in my example of the if and else, what they're going to copy most of the setup, change something, and say, of course, I have two tests running, they're both working, great, I can move forward. But obviously, this is not exactly what we want, and for that, we need, as manager, to review code, to teach developers how to review their own code, to write and review other people's, so we can create some kind of bar of test quality. Next question, can unit tests be created by people who did not write the code itself? I did that. It really depends on the code. It's kind of risky because if the code is complex and ugly, and it's kind of a spaghetti code, and you write unit tests, and then you ask, okay, I put 3 into that, and it comes out 5. Is it okay? Is it not okay? If I'm wrong and the 5 is not okay, but I put an assert on that, then something maybe the test will be locking in bad functionality. So it can be done. I've done it on small, not complex Python code. So I actually wrote tests for that. And it is possible. And sometimes people leave the project and somebody has to write tests for them, so that's possible as well. There are tools for that, like approval tests, that you say, well, the code works. The 3 actually does provide a 5. That's how it worked for the last year, then that's okay. So it is possible to do. The quality of these tests, that depends, because again, it really depends on the code itself. I'm going to answer 2 more questions, then we'll go to the sweepstakes, and the rest I will answer in as a blog post. As a manual tester, can I help somehow developers with unit test? Oh, yes. Just sit with them and tell them, these are the scenarios that I'm going to test. These are the important ones. These are where, if you can do the automation, it will help me because I'll have more time to work on some other more complex stuff. Make sure that these things are working. Show me your proof and I'll be thankful. Yes, working together as a manual tester and even not a manual tester. And making the mindset that these are things are more important than others, this code is more important than the other, work with that. So yes, you can help. Last question I'm going to answer today, how to motivate developers to write unit tests. Violence and guns. The strategy is mostly and it says at the moment development manager has made unit tests as part of the definition of done. It doesn't help. Of course it doesn't help. It works with the mindset. That just saying you need tests will not work. There's going to be objections. It's going to be hard. The developers will tell you it is going to be hard. It is hard. The tool doesn't help. These are scenarios where the code is too complex. It works together with the education process of a new process, just like I described today. Start with the mindset. Tell them the goal. The goal is not to build something that we can push into Bitbucket. The goal is to provide something that works at the end of the road. And we want to get to this end as quickly as possible. That means we need those tests to prove that things are working now before we hand it over towards integration or testing and so on. Now, what are the most important things for the users? These are the things. Let's test these things. Let's make sure that these things are working. I'm changing my language. We have to make sure that these things work rather than you need to write unit tests. So there's a whole lot of thing part just putting them in the process as a task. It won't just work because the developers are not brought up that way. It's a new process for them. If you only added work to the work, which is already crumbling by bugs and so on, they will just not do it. There's be a lot of resentment, and they will say, as I've heard a lot of times, yes, unit testing works, but for other people, not for us. So it's not about learning the tools and saying you have to work this way from now on. If you want this to actually succeed in terms of implementation, you have to start with the mind, to start with why. Why are we doing this? How is it going to help the customer? How is it going to help us? We don't want as many bugs as we had before. So yeah, go back to the recording and do that. There's a few more questions. There's a lot more questions, but we're running out of time. Hey everyone, if you enjoyed this video, be sure to like, share and subscribe for more. Thanks for the support, and remember, live long and test.